Okay, so today is going to be about prime factorization, and we're going to cover LCM and GCF a lot. Number of factors and product of factors is going to be for tomorrow. So starting off with a review of what exactly a factor is. Factors are just numbers that can divide a number. They're also called divisors. So 5 would be a divisor of 10 because 5 can divide 10 into 2, which is a whole number. And 6 would not be a divisor of 9 because 6 divides 9 into 1.5, and that's not a whole number. And so we're going to do a few problems about factors, and you can ask any questions you have. So, is 12 a factor of 12,408? You can type your answer in the chat. And yeah, you guys are right. The answer is yes. So I'm sure you guys just did 12,408 divided by 12, which does give you a whole number. So 12 is a factor. Is 7 a factor of 365? Yeah, good. The answer here is no, because it doesn't divide into a whole number. Okay, and now on to what is a prime number. So a prime number is any number that has two factors, one in itself. And so an example of a prime number would be 17 because its only factors are 17 and 1. But 15 wouldn't be a prime factor because it has 1, 3, 5, and 15 as its factors, which is obviously more than 2. And on the left, you can see a helpful graph with all the prime numbers that are highlighted in yellow. So examples are 2, 3, 5, and 7. And now a quiz question, is 1 a prime number? And why or why not? All right, you guys are correct that the answer is no, but what's your explanation for why it isn't? It's a special number. Yeah, that's a way to describe it. Yeah, it's divisible by only itself. And so both of those basically work. The best way to say it is like 1 only has one factor. And so it doesn't have two factors, so it's not prime. And so we're going to do a few problems about prime numbers. So is 91 a prime number? All right, good. This one's a commonly asked trick question, but the answer is no, because it's divisible by 7, 13, 1, and 91. Is 101 a prime number? Yep, that's good. It is a prime number because it doesn't have any factors besides itself and 1. Okay, so now we're going to review prime factorization. So it is where you find the prime factors that multiply to become a number. And since each prime number has only a factor of itself and 1, every number has a unique prime factorization. So we're going to take the number 2022 and find the prime factorization of it using a factor tree, which is basically the best way to represent prime factorization, so you don't get lost or make mistakes anywhere. So first, we see that it is divisible by 3 because if you add up all the digits, then that equals 6, which is a multiple of 3. So we divide that by 3 and we get 674, which we see is even and therefore divisible by 2. And so finally we get 337, which is a prime number. So our final prime factorization is 2 times 3 times 337. So try finding the prime factorization of 2025 using a factor tree. Yeah, Akshat, this first day is actually like basically a lot of the same stuff that we taught in pre-algebra, but don't worry, because like every other day is going to be completely different. It's just this day to set up the content. And what's great is that I think all 4 of us were in that pre-algebra class. Yep, so it looks like you guys remember what you learned. It would be 3 to the 4th times 5 squared. And so we're going to draw a factor tree here. So maybe this isn't the best example of factor tree, but we can see that it's clearly divisible by 5. So if we do that first, and then that gets us 405, then we divide out another 5, so that's that 5 squared. Then we're left with 81, which we know is 3 to the 4th power. And so our final prime factorization is 3 to the 4th times 5 squared. Okay. You can try finding the prime factorization of 2021. This one doesn't really have an easy way out. So basically just test every prime until you find one that works. And yeah, the answer would be 43 times 47. So this number only has prime factors. So there's no really easy way to do it. Oh, okay, so I didn't add transitions here, but, oh, and also, okay. That's really interesting. Let's just move past this. It's kind of messed up. But yeah, that's the prime factorization of 2,700. And so it's like a more expanded way to do it. So like you might see that you can divide that easily by 10 and then 270, easily divided by 9 and then 30. And then you just go all the way down. So yeah. Okay. So here are some problems, and you'll have 6 minutes to try and solve as many as you can. Go ahead now. Okay, it looks like you guys got most of them right. So let's go over the answers. First, the prime factorization of 1,245. Well, first you can see that it is divisible by 5. So you divide it by 5 and you get 249. 249 would be divisible by 3 because its digits sum up to 15. And so you divide it by 3 and you get 83. So your final answer is 3 times 5 times 83 because 83 is a prime and can't be broken down any further. Now for 1776, first you divide it by 2. You can divide it by 4 2s. Then you're left with 111, which is in fact 3 times 37. So your final prime factorization is 2 to the 4th times 3 times 37. 387. You know it's divisible by 3 because of the divisibility rules. So then you get left with 129, which is 3 times 43. So good job if you got that correct. And then 9,583. You can see it's divisible by 7 by the double the last digit rule, and then subtract that from the rest of the number. Or you could just put it in your calculator, to be honest. And then you can see that 1,369 is 37 squared. So that is kind of tricky to know. Then finally, the really big one, 40,320. So here it is really ideal to create a factor tree. You might not need a factor tree for smaller numbers, but here it's really helpful. So we're going to make a factor tree like this one right here. And so you can easily see the steps we took in dividing all the numbers and how it leads to the answer of 2 to the 7 times 3 squared times 5 times 7. Does anyone have any questions on these practice problems? Oh, that's fine. Okay, great. So we're going to move on to greatest common factor and least common multiple. As a review for all of you. So greatest common factor, that's what GCF stands for. And it refers to the greatest integer that can divide all the given numbers. The GCF can be 1 if, for example, both numbers are prime. So the greatest common factor of 25 and 60 would be 5. That's because 5 is the greatest factor of both numbers. And there's like no other integer that can divide those numbers into an integer, no larger integer. Then the GCF of 150, 270, 330 would be 30, because 30 must divide all of those numbers and be the largest integer that divides them equally. So the second term we're going to cover here is least common multiple, or LCM. And that refers to the smallest integer that can be divisible by all the given numbers, which can also equal one of the numbers that you're given. So for example, if you're finding the LCM of 25 and 60, that would be 300, because 300 is the smallest number that's divisible by both 25 and 60. As for 150, 270, and 330, the answer for LCM would be 14,850, because that's the smallest number that's divisible by all 3 of the given numbers. And so that's a really large number, and it'd be pretty hard to find if you were just given that. But there is an easy way to do it using prime factorization, which we're going to go into. So starting off with how to find greatest common factor. Do any of you remember this step? or maybe have an idea of how to do it from last week. Even if you just maybe know part of it, the first step, you can put in the chat. We'll start with the first step. What's the first step in finding GCF the easy way? All right, well, I'll go ahead and say then. So the first step would be to find the prime factorization. So hopefully that jogs your memory. The shared prime factors. So what you're looking for here is to find the shared prime factors of A and B, because those will multiply out to become the greatest common factor. And this can also be applied to like if you're solving the GCF of 3 numbers, 4 numbers, whatever. So for example, we're going to find the greatest common factor of 231 and 497. 231 equals 3 times 7 times 11, and 497 equals 7 times 71. So type in the chat which one is the common factor in those two. There's like one common factor present in both prime factorizations. Which one is it? No, I'm just asking you for which one is the common factor. Like, look at the prime factorizations on the screen. Which factor is the same between both of those? Yeah, great. The answer would be 7 because you can see it in both the prime factorizations. And so here the greatest common factor would be 7 because all you're looking for is which factors are shared. Now we're going to find the greatest common factor of those 3 numbers. So first step is always to find the prime factorization of all of them, which you can see written out here. Oh, and then, okay. So you can see all the prime factorizations, and then you look for whichever factors are shared by all numbers. So you can see all of them have a 3 and a 5. So our answer here would be 15. But you can't, oh, sorry, I accidentally clicked that too fast. All right, but there's going to be more problems. So, but you can't like put 5 squared because that's only present in 9,300. You can't find a 5 squared in the other numbers. So that can't possibly be a greatest common factor. All right, solving least common multiple, and I'll be careful not to click too fast this time. So take the prime factorization of the numbers, and then first you have to list all the prime numbers found, but only take like the highest exponent or the biggest number or the most number of times for which they occur for any given prime, which might be a little bit confusing. So it makes more sense when we go to examples. So find the LCM of 231 and 497. Here are the prime factorizations. And so basically take every distinct prime number there and find which one has the highest exponent in each number. This one doesn't really have any exponent. But try writing out the prime factorization of the LCM for this problem. So we can see that all the exponents in these are just ones. And so the four distinct primes that are in this are 3, 7, 11, and 71. So our LCM would have 3, because we only have 1 3 here, and then 7. So whichever one has the highest exponent. Since both of these have an exponent of 1, we can just have 7 to the first power, or just 7. Same for 11 and 71. But like say this was like 7 squared, then you would only put a 7 squared here because that's the bigger exponent. So hopefully that makes sense. And so let's see, the LCM would be 3 times 7 times 11 times 71, which is 16,401. All right, example 2, find the least common multiple of those 3 numbers when here are the prime factorizations. So first list out like what are all the distinct prime numbers in this problem, and then go through each and just find whichever one has the highest exponent. Yeah, okay. I'll wait for you guys to give your answers. All right, yep, you are correct, Akshat. It's a great job. Yeah, very nice. I can see that you understood this. So let's give an explanation. So we know that the distinct primes here would be 2, 3, 5, 7, 31, and 73, because everything else is just a repeat of those numbers. And so we look for the highest exponent for 2. Well, there's only one 2, that's 2 squared. So then we put that right here. And now we look for the highest exponent for 3. So that would be this 3/4 right here. So I put that there, and we basically ignore all the other 3's because we're looking for the least common multiple. So this 3, like if something's multiplied by 4 3's, it's also multiplied by 1 3. So that still works. And then 5, this is the highest exponent for 5, so 5 squared. Then 7, 31, and 73 all just have an exponent of 1 as their highest exponent. So nice job. And now we're going to see an interesting property that can help you find LCM and GCF more quickly. So this property is that, say you're given 2 numbers a times b, then the greatest common factor of a times b multiplied by the least common multiple of a and b, sorry, I think I said a times b, just a and b, equals a times b. And so given that equation, you can also rearrange it easily to be least common multiple of those 2 numbers equals the product of those numbers divided by the greatest common factor. Or you could rewrite it as the greatest common factor of those numbers equals the product of those numbers divided by the least common multiple, because that's just algebra. And we can use that to solve problems where it might be like faster. This method might be faster in some occasions than just like slowly finding the LCM or GCF using prime factorization. So say we're trying to find the LCM of 90 and 81, and you should try to use the property above. So here, it already gives you A and B, and the greatest common factor of A and B is relatively easy to find. So we can use that property to find LCM. All right, so I'll wait for 2 or 3 answers. Okay, well, Akshat was correct again. So we can see that the greatest common factor of 90 and 81 would be 9, because there's no larger integer that can divide both of them equally. And then obviously we already know A times B because they gave us that in the question. And so given the property that we know, that would mean that the LCM, which is what we're trying to find, equals 90 times 81 divided by the greatest common factor, which is 9. So it's basically the same thing as 9. I'm sorry, that's the same thing as 10 times 81, which is 810. All right, you used 2 ways. What's the other way you used? Did you just find the LCM using prime factorization? All right, go ahead. Oh, okay, I see. So what you did is you did 81 times 90 first, and then after you divided by 9. Yeah, that would be slightly harder, but of course it still works. All right, second question. If the greatest common factor of x and y is 13, and the product of x and y is 247, find the LCM. So basically same thing. It gives you 2 of the things you need to know in that first equation, and then you need to find the third thing. Is it way trickier? Let's see. I think there's an easy way to simplify this. So let's take this original equation. Greatest common factor times least common multiple equals A times B. So what is the greatest common factor here? That would be 13. And then what you're trying to find is the least common multiple. And then that equals 247. So if I write it like this, then do you guys know the answer? Yeah, excellent. The answer is 19. 19 is the least common multiple of those two. Basically just a matter of figuring out like how the information they provide can be fit into the formulas that you know and how that gets you the right answer. All right, let me get rid of these lines. So here are some practice problems. Find the greatest common factor and least common multiple of 576 and 336. You can use a calculator here. And this one does not use the properties that we just learned, so don't get confused. You just have to use your prime factorization. You're 9 years old. How old is everyone else then? I mean, obviously I'm the oldest here, so. What grade are you going into, Akshat? 4th grade? Okay, he's 10. 5th grade. All right. So you aren't the youngest. Okay, well, back to the math. So 48 is the greatest common factor of these two, actually, because think about it, like least common multiple, it has to be bigger than those numbers. It can't be smaller than those numbers. I mean, it can be equal to those numbers, but it can't be smaller because it's least common multiple, you know. So yeah, we're going to do a few Kahoots at the end. Okay. So do you guys want to find the LCM of this, or do you want to just go to the explanations? Oh yeah, no worries. Okay. I'll give you a few minutes to find the LCM. Oh yeah, it's pretty easy to get confused between the two. Okay, so you are correct. The greatest common factor is 48. The LCM is 4032. So good job. And here's the process you should use while doing that. So number one, find the prime factorizations of both. And so then you can see greatest common factor is basically like which ones they have in common. So both of them have 2 to the 4th because this one has 6 2's, but this one only has 4. So you can only take 4 because that's what they have in common. And so they have a 3 in common too. They don't have a 7 in common because only 336 has 7 in its prime factorization. So you multiply the ones that are in common, and then your answer is 48. For LCM, you kind of do the opposite. You find like whichever one is the greatest. So 2 to the 6 times 3 squared times 7, and 4032. All right, problem 2. Find the LCM of A and B given that the greatest common factor is 16, and the product of A and B is 1/4 the square of the LCM of A and B. So this one's kind of an algebra problem, and it can be pretty complicated. So just as a hint, I'll write out the formula. So least common multiple times greatest common factor equals A times B. And you try to fill that in using the what you know from the problem, and then solve for LCM. Basically, pretend like LCM is your variable and solve for that. Yeah, this problem is significantly harder, so it's okay if you guys can't get it. You're so close. All right, that's good. You want to keep trying, or would you like maybe some hints to push you along the way? Oops. Okay, I didn't mean to do that. I was trying to click on this. But okay, good, you got it right. So let's go through this step at a time because it is pretty tricky. So LCM of A and B is what you don't know. So you're trying to solve for that. And then let's see. You know, the question tells you that the greatest common factor is 16. So you just write that in right here, 16. So LCM times 16 equals A times B. And it also tells you something about what A times B is. A times B is 1/4 of the square of LCM. So LCM 16 times LCM equals 1/4 times, I'm just going to write L, 1/4 times L times L. Okay. And then now you just have to do some algebra to solve this. So multiply both sides by 4 and you get rid of this. And then this becomes 64 LCM. And then now if you divide both sides by LCM, you get rid of this. on both sides. And so then you're left with 64 equals LCM. I don't know what exactly you mean by 1 over 64. This explanation says the same thing as what I said. I don't think so. I mean, like, if you're saying 1 over 64 as your answer, then no, that's not the correct answer. Okay. Another question. How many positive integers less than 100 are multiples of 2, 3, and 5? So they have to be multiples of all three of those numbers. They have to be multiples of 2, 3, and 5. Yeah, okay, that's right. So 30, well, not the answer to this question, but it's a step in the process. So 30 is what all of our positive integers must be divisible by, because they have to be multiples of 2, 3, and 5. So basically this question is asking you, how many positive integers less than 100 are divisible by 30? Yeah, nice job. So for speaking of this in like least common multiple terms, the question is asking you for the LCM of 2, 3, and 5, which Jivitesh found was 30. And then we find how many positive multiples of 30 there are that are less than 100. So the answer would be 3 positive multiples, 30, 60, and 90. Yeah, it's basically a question of interpreting the question in the right way. So something has to be a multiple of 2, 3, and 5. So that means that you should find the least common multiple of 2, 3, and 5, if that makes sense. All right, question 4. Mrs. Chandler has a class of 20 kids, and she wants to give each student at least one pencil to use. Pencils are sold in packages of 12, and Mrs. Chandler wants to give each student the same number of pencils with no extra. So what is the smallest number of pencils she can buy? Packages of pencils, sorry. Yeah, the answer here would be 5. So this is asking for you to find the LCM of the number of kids and the pencils per box, because you want to give everyone the same amount with no extra left over. And that LCM would be 60 pencils. So since pencils are sold in packages of 12, then you need 5 packages of pencils to get 60 pencils. All right. This one is a bit of a trickier one, but let's see what you can make of it. Yeah, the answer is 36. So the secret to this problem is basically like treating veggie and hamburger patties together. So hamburgers are sold in packages of 8 and veggie burgers are sold in packages of 10. So we combine them together to say like, you must have at least 18 burgers if we have one package of both. That's like the least possible scenario because both types of burgers have to be served. And then also we must factor in the packages of 12 buns. So this is basically asking us for the LCM of 12 and 18, which is 36. All right. And one more problem. Johnny had a full bag of apple seeds. He found that if he repeatedly removed the apple seeds 2 at a time, 1 seed remained in the bag at the end. And similarly, if he repeatedly removed the seeds 3, 4, 6, 5, or 6 at a time, 1 seed would always remain in the bag at the end. What is the least number of seeds he could have in that full bag? This one can look hard, but there is an easy trick. So basically, you should find the LCM of 2, 3, 4, and 5, and then add 1 to it because that's the 1 seed left over. So do that. Find the LCM of 2, 3, 5, 2, 3, 4, 5, and 6, then add 1 to that. All right, so how are you guys getting along with this problem? Are you stumped or, oh, okay, never mind. Okay, you did get the answer, 61. That is correct. So he has 61 seeds in this bag. So pretend like, we can just pretend like the problem just says, if he removes the seeds 2 at a time, 3 at a time, 4 at a time, 5 at a time, or 6 at a time, there's no seeds left. And so then that, basically that's just asking for the LCM of 2, 3, 4, 5, all those numbers. But then since there is 1 seed remaining in the bag at all times, we just have to add 1 to that LCM. And then that tells us how many seeds are in his bag. Right, so we're going to skip the rest of these problems since they're basically just repeat the same concepts. And we can come back to them later if we need to. Okay, so we're at the halfway point in the class, and we're going to take our standard 5-minute break. All right, so go ahead, do whatever you need to do, and return at 10:39. All right, on to today's activity. So here are going to be two Kahoots. We can go ahead and do this one first, because why not? Hopefully there's no mistakes with the questions, although it's really easy to have mistakes in Kahoots. Okay, so go ahead and join. I'll put the game pin in the chat if that makes it easier. Do we want music or no music? All right. The other two of you join. Okay. All right. Correct me if I'm pronouncing your name wrong, but Bharati, if you want to join, go ahead and do so in the next minute.
Okay.
Okay, so let's start. LCM of 14 and 18. Yep, the answer here is 126. The prime factorization of 14 is 2 and 7. And for 18, that would be 2, 3, and 3. So for LCM, you have to do 2 times 7 times 3 times 3. What is the greatest common factor of 21 and 14? Oh, wait, I think this question is messed up. Greatest common factor, right? Okay,
It should be 7, yeah. What happened?
yeah, okay. Let's skip that. Sorry about that. Yeah, I should have said least common multiple. Right. LCM of 32 and 18. Good. This would be 288 because 32 is 2 to the 5th, 18 is 2 times 3 times 3. So LCM, you take the highest exponent, that would be 2 to the 5th times 3 squared. Okay. This one's actually greatest common factor. The answer is 2. Because, so you can see using your divisibility rules that 188 would not be divisible by 3, which means it's also not divisible by 6. And then all you have to check is 11. Yeah, this one. The smallest possible number is 12, like you guys put. All right, so for future questions, I'm probably just going to skip that question when there's like 15 seconds left, just so we can get through everything. Well, it looks like you didn't misclick. Okay, so this one is 96. So first 3 non-zero even numbers, those would be 2, 4, and 6. And so if something is divisible by those 3, then we need to find like the least common multiple of them. So that would be the least common multiple of 2, 4, and 6 is 12. So this question is just asking you for the largest integer under 100 that is divisible by 12. And so that would be 96, because 98 is larger, but it's not divisible by 12. Okay, good job. That would be 24. So here you just find the prime factorization of both. And then find whichever ones are shared. All right, so a bit of a more involved one. Okay. So the answer here is 8. And so for first you find the greatest common factor of 128 and 48, which would be 16. And then the greatest common factor of 32 and 24, which is 8. And then you have to find, there's another GCF. So you have to find the GCF of 16 and 8. And so that would be 8. Okay, so for this one, LCM of 6 and 14 would be 42, I believe. And then LCM of 12 and 18 would be 36. So now you have to find the LCM of 42 and 36, which would be 252. Yeah, Russian is bad. All right, let's continue. All right. So here, LCM of 4 and 7, that would be 28. That's the smallest number that's divisible by both 4 and 7. So then you have to divide 28 by the greatest common factor of 32 and 100. And that would be 4. So basically the question is 28 divided by 4. Okay, nice job. So this is something similar to ones we've done before. So they have to be a multiple of 2, 3, 4, and 6, meaning that you find the LCM of those numbers, which is 12. So then basically the question is asking how many positive integers less than 80 are divisible by 12. And so you can see like 12, 24, 36, 48, 60, 72. But then the next one would be 84, which is too big. So there are 6 positive integers that fall into that criteria. Nice job. Okay. So LCM of that divided by GCF. So we can solve for GCF first. That would be 3. And then LCM would be 450. If you just use like your prime factorization rules to solve for that. So yeah. This one's like the pool problem. Yeah. So the smallest number that's divisible by both 24 and 6 is in fact 24. Yeah. Answering the question. So you play the piano every 2 days, you play the drums every 7 days, and you played both last Friday. What day of the week will you play both instruments again? Yeah, so this one, you find the LCM of 2 and 7, which is 14. And then you also have to know that like 14 days after a Friday is also a Friday, because that's exactly 2 weeks. All right, so we're split, but this one over here is the right answer. So this one would involve finding the prime factorization of all 3 of them. So 360 is 3 times 3 times 2 times 2 times 2 times 5. 245 is 5 times 7 times 7. 18 is 2 times 3 times 3. Then you find the highest exponents for each number. and put them together to find the prime factorization. All right, true or false? Okay, so this one is in fact true. Okay, yeah, don't worry about it. So two numbers have a greatest common factor of 1. That means both of those numbers are prime. So for example, we'll take 2 and 3. Those have a greatest common factor of 1. And then if two numbers are prime, their LCM is always going to be like just them multiplied together. So the LCM of 2 and 3 would be 6, for example. And you can see that that applies for any two primes. So it's like a definition problem. Is that the correct definition? Yes or no? And yes, greatest common factor equals the product of the prime factors that those two numbers would have in common. All right, good job. This one I thought was going to be kind of trickier. So very nice. All right, so you guys should also get this one if you got the previous one. You, in fact, did not misclick. That is the smallest integer to be divisible by all given numbers. And so the other ones, divisors that divide a number, that would be factors. The prime factors that multiply to become a number, that's prime factorization. Yeah, the answer is 62. This is basically the same thing as the Johnny Appleseed one, if you remember that from the slides. All right, answer here is 42 days. So I'll just ask you for the least common multiple of 6 and 7. Hey, good job. Greatest number of kids for a row. So that's just asking greatest common factor. All right, last question. Okay, this is a bit of a weirdly worded one, but basically just least common multiple of 12 and 18. All right, podium. Okay, good job, all of you. And now we have one more, which we might not get done with, but that's all right. We'll just get through some of the questions for practice. All right, so go ahead and join if you want. Right. 140. That would be 2 squared times 5 times 7. So make sure you guys draw out factor trees. All right, so 140. If you divide it by 2, you get 70. Divide that by 2 because you can see that it's easily divisible by 2, and then you get 35. And then 35 splits into 5 and 7. And so you can't go any further from that. So that's your prime factorization. Yeah. Enter here 2 cubed times 5 because 48 is 8 times 5 and 8 is 2 times 2 times 2. Okay, good job. And also, another thing you can do to kind of like cheese these questions is just like type every option or just solve every option and see whichever one adds up, whichever one multiplies out to 507. Good job, you guys got this. Yeah, this one is 2 times 3 times 5 times 7. 3 times 70 is like accurate. It goes to 210, but 70 can be simplified down further. Oh, this question is messed up. Sorry about that. It should be green. Yeah, okay. Good know. Yep, this one is 3 times 19 because neither of those can be simplified down further. Yep, the answer here is 3 cubed times 5. Blue is also, technically correct, but 9 can be simplified further. All right, so we're just going to do a few more. And then we'll end the Kahoot early. Okay, good job. This one is 3 times 5 times 11 times 17. This is probably a good one to use a factor tree on. All right, so let's do 2 more. good. 2 cubed times 3 squared times 5. And last one. And factorization of 2002. Actually, if you look at the options, you can see which one is right immediately without even solving for it. Yep, so this one, it obviously has to be yellow because that's the only one with the 2 in it. And you can see that this number is even, so it's clearly must have a 2 in the prime factorization. So the other ones can't possibly be correct. All right, so we'll end the game here. All right, good job. And okay, so music's still playing in the background. So to finish up, we will have homework. And you guys have seen this homework, these homework problems before, but you can go ahead and attempt them again if you want to see what you remember. For larger numbers like these, don't get intimidated, but just take their prime factorization one at a step, just like continually removing numbers and using the divisibility rules until you get it down to its base. All right. So, does anyone have any questions? Oops, why do I keep putting on that? Okay, if none of you have any questions, then you are free to go. Tomorrow we'll be learning a bunch of new concepts, so it'll probably be a bit more interesting. But yeah, thank you for participating, and you're free to leave.
Bye.
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 Bye.